Hi, people. This video is on identity equations, and you'll find it really helpful to have your formula sheet in front of you while we're going through this because the formulas are going to really help you out because we're literally going to be using our identities to help us solve these equations. So, how are these identities going to be useful to us? In this example right here, we know that we've got cosine squared and sine squared. So these are kind of like two different variables right here. So I'm trying to solve one equation with technically two different variables, and that makes things really difficult for me. So I'm going to do some kind of substitution to help me out with this to make things easier for me. So we're going to use our most classic trig identity, which is sine squared plus cosine squared is equal to 1, because this is an identity that links sine squared and cosine squared together. So I'm going to go ahead and write this out. Sine squared plus cosine squared is equal to 1. But then I can isolate one of these variables right here, and it really doesn't matter which one you isolate. Like either way it works. So I'm going to isolate sine squared just because I randomly chose to do that. It really doesn't matter if you isolate cosine squared, that works as well. So if you look right here, I can copy down this 2 cosine squared theta as is. And then now when I see sine squared theta, I can replace it with 1 minus cosine squared theta. And then say that that's equal to 1. Like just copy the rest of this equation down right here. And now that I've done that, I can go ahead and do like an a substitution to make things easier on me. You don't have to do this. It's up to you. I'm going to say this is 2a squared minus 2 times 1 minus a squared equals 1. This is a squared. This is also a squared. So I'm going to go through and finish solving this. Distribute the 2 through. Collect these guys together. Move the 2 over, and I get a 3. And then I can divide by 4. But lastly, I'm going to square root. So right here, I'm going to square root 3 over 4. And the square root of 3 over 4 right here must have a plus or minus in front. For some reason, we always forget this plus or minus, and we can't forget this plus or minus. It's so important right here. Now, I cannot square root 3 evenly, but I can square root 4 evenly. So right here, what ends up happening is we actually end up getting plus or minus 3 over 2. Okay, so now that I've done that, we know that A is cosine of theta. So here I can say that the cosine of theta is equal to plus or minus root 3 over 2. This is a special value. So what I'm going to do is now find my related acute angle by drawing this out right here. So if I look for where cosine is root 3 over 2, I'll have root 3 here, I'll have 2 here, this is a 1. This works if this angle right here is 30 degrees. Okay, so that means that my angle is going to be 30 degrees. We're looking for the answer between 0 and 360, but because this is plus or minus root 3 over 2, this means that our answers are going to be in all 4 quadrants because cosine is positive or negative in all 4 quadrants. So we actually will end up getting 4 different answers in all 4 quadrants where your related acute angle right here is going to be 30 degrees. So in quadrant 1, our first answer for theta is just plain and simply 30 degrees. In quadrant 2, our answer for theta is going to be 180 minus 30, or 150 degrees. In quadrant 3, for theta right here, this is going to be 180 plus 30 degrees, which is 210 degrees. And then in quadrant 4, I'm going through this pretty quickly because hopefully at this point in time, this part right here is pretty easy for us because this is our third day of solving equations. Our answer in quadrant 4 is 360 minus 30, so this would be 330 degrees, which means that my 4 solutions are 30 degrees, 150 degrees, 210 degrees, and 330 degrees. And I'm good to go with this question here. Now, in number two, it says solve the equation tan squared theta plus 3 secant theta equals -1. So in this question, I need to look back at my formula sheet and find the formula, or the identity, excuse me, that links tangent and secant together. And we know that tangent squared theta plus 1 is equal to secant squared theta. So I'm going to write that down. Tangent squared theta plus plus 1 is equal to secant squared theta. Now, in our last example, right up here, I said you could isolate sine squared or cosine squared, it doesn't matter. And the reason why it didn't matter is because both of these were sine or cosine squared. However, in this equation, we can only isolate one thing, and that is the tan squared, because that is tan squared right here. We do not have an equation or an identity that uses just secant right here. So what I'm going to do is I'm going to isolate this tan squared. So this is going to be secant squared theta minus 1. And now that I've done that, I can replace tan squared theta with secant squared theta minus 1, and then I can just copy the rest of this equation down. Now, to make my life easier, I'm going to do a substitution. Again, this is not required. You do not have to do this. This turns into a squared minus 1, and then this turns into 3a. Now I can say that this is a squared plus 3a. I can move this 3 over, and I end up getting plus 2. I'm going to go through and factor this. So then a is -2 and a is -1, which means that secant of theta equals -2 and secant of theta equals -1. Well, what does that tell us? I can now do the reciprocal of secant of theta, and I can now say that this right here is going to be cosine of theta is equal to -1/2, and that because this is -2/1, I can just do the reciprocal of that value. And here I can say that the cosine of theta is equal to the reciprocal of -1, which is still -1 right here. Okay, so and neither one of these is an answer that's going to be crossed off, because it's possible for cosine to be -1/2, and it's also possible for cosine to be -1. In this right here, I need to find my related acute angle, and my related acute angle is going to be the inverse cosine of 1/2. I'm going to use my special triangles, and I know that when cosine is 1/2 right here, this related acute angle is going to be 60 degrees. I'm going to bring this up here. Okay, so now that I've done this, this is again for cosine of theta is equal to -1/2. We know that our related acute angle is going to be 60 degrees. However, cosine is going to be negative, and we know that cosine is negative in quadrants 2 and 3. And we also know that our related acute angle is 60 degrees. So our first answer in quadrant 2 is going to be 180 minus 60 degrees, or 240 degrees, or 120 degrees. And then in quadrant 3, our answer for theta is going to be 180 degrees plus 60 degrees. So our answer for theta here would be 240 degrees. And then lastly, right here, so we're done with this piece over here. We need to do what's going to happen right here for cosine of theta equals -1. So now I'm solving this one over here. And cosine of theta equals -1, we can look at this two different ways. One way is on the circle. Remember, cosine is x over r. I want x over r to be equal to -1. This coordinate right here is -r0. So when I do x over r, it would be -r over r, which is -1. So that means right here that theta is 180 degrees. But we also know it's 180 degrees because right here, cosine is equal to -1 at the second critical interval, which is 180 degrees as well. Okay, so that means that my two solutions are 120 degrees 180 degrees and 240 degrees. Now, before we do anything else, there's something super important that I did not do here that we have to make sure we do whenever we have any type of like reciprocal equations here. And that is we have to state our restrictions. So over here we have tan of theta in our original problem right here. And so tan of theta is sine over cosine. So this means right here that cosine of theta cannot be equal to 0. So we have to state that restriction here. And then the same thing here for secant of theta, because secant of theta is 1 over cosine of theta. That also means that cosine of theta can't be equal to 0. So this is our restriction here. But luckily, cosine of theta is equal to 0 at 90 degrees and 270 degrees, which is not one of our solutions here. So none of these solutions is extraneous, but that's something that we have to consider always. All right, and that's it for this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.